Good morning, scholars. I hope that all is well with you and that you had a great weekend. We are now entering into week 3 of Summer Academy. So hopefully you've now gotten used to a little bit of how things work. Hopefully you're keeping up with your assignments. And most importantly, if you are struggling, you are learning the importance of asking questions. When you go off into high school, you got to learn how to ask questions. Otherwise, all the teacher can assume is that you know what you're doing. With that being said, we're going to move into topic number 4, which focuses on fractions. So simply put, we're going to add, subtract, multiply, and divide fractions, both computation-wise and within word problems. Fractions have been a weak subject for a lot of folks, so it's important to pay attention, put it into practice, and you'll do a good job. A few reminders as we get into the computation involving a fraction. First and foremost, before you begin any work, make sure all of your numbers are fractions. So, for example, the number 6 is not a fraction. However, we can always make it a fraction by putting it over 1. What that means is taking that number and making it a fraction by putting it over 1. So anytime you have a whole number, make it a fraction. It makes things easier. Second, before beginning any work, change any mixed numbers to improper fractions. So if you have 5 3/4, remember to change it to an improper fraction, multiply the denominator times the whole number, and then add the numerator. So 4 times 5 is 20, and 20 plus 3 gives you 23. So 23 over 4. And then last but definitely not least, at the end of each problem, reduce the fraction if you can possibly reduce it. So that means if you get 9 over 12, that is not your final answer. You need to reduce it. Always reduce to lowest terms. Always reduce to lowest terms. It's little things that stop you from getting full credit on a problem that you otherwise did correctly. So with that being said, we're going to look at multiplying, dividing, and adding and subtracting fractions. There are different sets of rules depending on what we're working with. Let's start with multiplying. Multiplying is pretty straightforward. Multiply the numerators, then multiply the denominators, and you're going straight from left to right. So you're going straight line left to right. Straight line left to right. So with that, let's go ahead and look at some examples for multiplying, which are examples 1 and 2. So example 1, 4 over 7 times 2/3. So that's 4 times 2, which is 8. 7 times 3, which is 21. So we finished our multiplication. 8 and 21 cannot be reduced, so this is our final answer. That's our final answer for that multiplication. For example 2. Now notice that there are 2 things happening here. 1, you have a whole number, and 2, you have a mixed number. So the whole number, remember you take the whole number, put it over 1. For the mixed number, 5 times 1, and then you add 4 to it. So that's going to give you 9 over 5. So now everything is set up to go for our multiplication. 6 times 9, which will give you 54. 1 times 5, which gives you 5. So you have 54 over 5. 54 over 5 cannot be reduced, so this is your final answer. In Algebra 1, it is okay for you to give your final answer as an improper fraction. However, if it makes you more comfortable to give it as a mixed number, this would be 10 4/5. So either of these examples would be accepted as final answers. Either one would be accepted as a final answer. Let's divide. So division uses the keep, change, flip method. You may have heard this in middle school. The keep, change, flip method. So that's keep the first fraction, change division to multiplication, and then flip the second fraction, and then you go ahead and multiply it. So if you look at the example that was provided, 1/5 divided by 1/4, you keep the first fraction, change division to multiplication, and then you flip the second fraction. Flip means exactly that, flip it over. And by doing that, now you changed it into a multiplication problem, so you solved the multiplication problem. 1 times 4, 4. 5 times 1, 5. And that's how that problem would work. So now let's apply it with 2 more examples. So example 3, you have 1/6 divided by 1/4. So again, keep the first fraction, change division to multiplication, and then you flip the second fraction. Literally just flip it over. Now we can do our multiplication. 1 times 4 is 4. 6 times 1 is 6. Then 4/6 can be reduced. Remember, we always reduce our work. Divide by 2, and you're left with 2/3. And you're left with 2/3. Let's do the exact same thing with a little bit more complicated example. So 2 1/3 divided by 2/5. So again, 2 1/3 needs to change to an improper fraction. 3 times 2 is 6, plus 1 is 7. So 7/3. Change division to multiplication, and then you flip the second fraction over. 5/2. So after that, it becomes a multiplication problem. 7 times 5 is 35. 3 times 2 gives you 6. 35 and 6 cannot reduce, so you can leave your answer as 35/6, or you can change it to a mixed number, which is 5 and 5/6. That's that, problem's over. So now we've done multiplication, we've done division. Now we'll get into adding and subtracting. Adding and subtracting is saved for last because there are 2 different scenarios for adding and subtracting. Whether the denominators are the same or if the denominators are different. So let's go ahead and tackle that beast. So example 5 and example 6 is where we will start. With example 5 and example 6, you'll notice that the denominators are the same. The denominators are the same. And I'm blowing it up just to provide more room for each problem. So example 5 and example 6. If the denominators are the same, then you can just go right ahead and subtract. Go right ahead and subtract, no big deal. Or add. So in the problem 5, notice that the denominators are the same. So you can go right ahead and add. Denominator stays the same. You just have 5 plus 3. So 5 plus 3 gives you 8. 8/16 can be reduced. Both numbers are divisible by 8. So you're left with 1/2. You are left with 1/2. So when you subtract, So remember, one of the rule of thumbs for subtraction is to go ahead and convert those mixed numbers to improper fractions. So 15 times 2 is 30, plus 7 gives you 37. 15 times 1 is 15, plus 4 is 19. So now we've gone from mixed to improper, but notice the denominators are still the same. So we keep the denominator and subtract the numerators. 37 minus 19 gives you 18. 18 over 15 can be reduced. Divide the top and the bottom by 3. And that gives you 6 over 5. And if you don't want to leave it as an improper fraction, you can change it to 1 1/5. Now, some of you might be saying, well, Mr. O, I didn't have to change them to improper fractions in order to solve that out. And that's fine if you chose not to do it that way. It will work just as easily if you do it as is. The way you would do it is 2 minus 1, which gives you 1. So you would take 2 minus the 1, which gives you 1. And then you would take the 7 over 15 minus 4 over 15, which gives you 3 over 15. Do remember, you still have to reduce. Divide top and bottom by 3. That still gives you 1 1/5. Now, this was a relatively easy example in which you didn't have to convert it. The reason why I tell you to convert to an improper fraction first is because that way you don't have to worry about borrowing with mixed numbers, because then that can get a little bit more hairy. But if that's something that you're used to doing from middle school and are comfortable with doing, by all means, do what works for you. Nonetheless, that's when the denominators are the same. When the denominators are different, then it gets a little bit more hairy. It gets a little bit more hairy because you need the denominators to be the same. That's point blank and period with adding and subtracting. Let me say that again. Adding and subtracting. When you are adding and subtracting, that's when the denominators must be the same. Period. When you're adding and subtracting. Multiplying and dividing does not need the same denominator. So let's go ahead and look at example 7. Example 7, you got 5 1/6 plus 2 2/3. So again, I'm going to go ahead and change my mixed numbers to improper fractions. 6 times 5 is 30, plus 1 is 31. 3 times 2 is 6, plus 2 is 8. So first thing was I changed them. So now I need the denominators to be the same. So I first asked myself, is there anything times 3 that will give me 6? Yes, there is. That's 2. So I'm going to take the second fraction and multiply the top and the bottom by 2. So the reason why I'm doing that is so that I can force the denominators to be the same. So I'm actually going to write that in a separate step, since, of course, these notes are going to Google Classroom later. That way you can see the progression. So we multiply the top and the bottom by 2. So that gives you 31 over 6 plus over 6. So now notice that the denominators are the same. The denominators are now the same. So now we can go and finish off this problem. keep the denominator and do 31 plus 16, which gives you 47 over 6. 47 and 6 cannot reduce, so this is your final answer. If you want to give it as a mixed number, that ends up being 7 and 5 6. Either way you want to give it. So again, remember, if the denominator is not the same, you are responsible to make it the same. Do not just go and think that you can just go and add and subtract all willy-nilly. Can't do that. Can't do that. Example 8. 4 over 5 minus 17 over 30. So these are regular fractions, so you don't have to worry about that. So in this case, we can go ahead and change the denominators over. We have to ask ourselves, is there something times 5 that will give me 30? Absolutely. That's 6. So we're going to take 4/5, multiply the top and the bottom by 6. So what we get from that, 6 times 4 is 24. 6 times 5 is 30. And sure enough, we have common denominators. So keep the denominator, subtract the numerators. And you're left with 7 over 30. 7 over 30 cannot be reduced. So that is your answer final. So that is your answer final. So now we've gone through each of the scenarios for adding, subtracting, multiplying, and dividing. Remember, adding and subtracting has the two cases, whether the denominators are the same and when they are different. So now we're going to go ahead and start navigating through word problems. Start navigating through some word problems. So just know that underneath, let's see, pull this up back out here. So there is a practice section with mixed practice with whole numbers, decimals, and fractions. So it's a mixture of all the different types. So I will put the answer key for this on Google Classroom so that you can get some more practice with all different types. So that's problems 1 through 16 here. In fact, I'll save you a little bit of that trouble. When these notes are posted to Google Classroom, the answers will already be there. So not to worry about that. Word problems. So remember, to solve a word problem, number 1, read the problem. Identify the key information in the problem. Determine how you will solve it, whether it's adding, subtracting, multiplying, or dividing. Solve the problem, and then lastly, look back to see if your answer makes sense. So let's look at our word problems. Example 1, during PE, a swimmer swam 2 1/3 laps on Monday and 1 3/4 laps on Tuesday. How many laps did this swimmer get through over the 2 days? So the clue here is they want to know how much did you swim over the 2 days. So that means you're adding them. So you're taking 2 1/3 plus 1 3/4. So now it's no longer a word problem, it's a computation problem because you set up what you needed to do. So let's solve it. 3 times 2 is 6, plus 1 is 7, so 7 over 3. 4 times 1 is 4, plus 3 is 7, 7 over 4. But our denominators are not the same. So notice in this case, there's nothing times 3 that's going to give you 4. There's nothing times 4 that's going to give you 3. So now we're going to force the denominators to be the same. So here's how we do it by force. The first fraction has a denominator of 3, not 4. So you're going to take 7 over 3 and multiply it times 4. Multiply the top and bottom by 4. 7 over 4 has a denominator of 4, not 3. So we're going to take the top and the bottom, multiply it times 3. Why would we do that? Because we're going to force the denominator to be the same. 4 times 7 is 28, and 4 times 3 is 12. Plus 7 times 3 is 21, and 4 times 3 is 12. So now if you notice, the denominators are now the same because we forced them to be the same. So now we can go ahead and solve the problem. 28 plus 21 is 49. 49 over 12. There's nothing that divides into 49 and 12 evenly, so you can leave this as the answer. Of course, this would be laps, since it was a word problem. Or you can give it as a mixed number, which would be 4 and 1/12 laps. That's it, problem's over. So again, you got to read it first, and you got to take a moment and interpret what are they asking you. In high school, you're not just going to be given the setup all the time. You've got to put in the work to figure it out. Example 2. Carlos's dog weighed 10 2/3 pounds last month. This month, the dog weighs 14 1/10 pounds. How much weight did the dog gain? So, this is where they started the month. This is where they're ending the month. You got to figure out how much the dog gained. So this is a subtraction problem. Take what you ended with minus what you started with. 14 1/10 minus 10 2/3. So, same rules apply. We're going to get the denominators to be the same. Before we do that, get rid of the mixed numbers. 10 times 14 is 140, plus 1, 141. 10 times 3 is 30, minus 2, plus 2, 32. So now we have to figure out next step. There's nothing times 10 that's going to give us 3. There's no whole number times 10 that's going to give us 3. And there's no whole number times 3 that will give us 10. So we do the switcheroo again. So we're going to take the first fraction, multiply it times 3. We're going to take the second fraction, multiply it times 10. So 3 times 141 is 423. And 3 times 10 is 30. 32 times 10 is 320. And 3 times 10 is 30. So now it's all set up and ready for us to go. The denominators are the same, so we keep the denominator. 423 minus 320 gives us 103. So that's 103 over 30 pounds, because that cannot be reduced. Or if you change this to a mixed number, 3 goes into 103 3 times with a remainder of 13. So those are the 2 ways that you can give that final answer. 2 ways you can give that final answer. All right, example 3. Example 3. A recipe requires 3/4 teaspoons of vanilla extract for a single serving of pudding. If you are making 12 servings of pudding for this week, how many teaspoons of vanilla do you need? So in this case, 3/4 to make one single serving. You're going to make 12 servings. So you could take 3/4 plus 3/4 plus 3/4 and keep doing this 12 times. Or you can take 3/4 and multiply it times 12. 3/4 and multiply it times 12, and this is probably the better option. So let's follow our multiplication steps. First thing we're going to do is take 12 and make it a fraction. So this is now 3/4 times 12 over 1. Now we multiply. 3 times 12 gives us 36. 4 times 1 is 4. And 36 divided by 4 is nice and neat. That's 9. So your answer is 9 teaspoons. 9 teaspoons. Example 4. Stephen can run 1 2/9 miles in 10 minutes. 1 2/9 miles in 10 minutes. How many miles can he run in 1 minute? So we want to know how many miles can he run in 1 minute. So this is 1 2/9 divided by 10. 1 2/9 divided by 10. So once again, what we need to do is to not just take the 10 and make it a fraction, but take 1 2/9 and change it into an improper fraction. So improper fraction, 9 times 1 is 9, plus 2 is 11. Divided by 10 over 1. So now let's start solving. Again, when you divide, you keep the first fraction, change division to multiplication, and you flip the second fraction. Now you multiply straight across. 11 times 1 is 11. 9 times 10 is 90. 11 and 90 does not reduce, so that means this is your final answer. 11 over 90 miles. 11/90ths of a mile is your final answer. So again, it's not a hard problem. It is a problem that does require you to put in a little work. Does require you to put in a little work. Let's navigate through the last 3 word problems. Example 5. In PE class, your first attempt at a vertical leap was 35 5/8 inches. Your second attempt was 37 7/8 inches. How much longer was the second attempt than the first? So in this particular case, we're looking at, you started with 35 5/8. You're at 37 7/8. You're trying to figure out the distance in between. That's a subtraction problem. So, in this case, remember I said earlier, you don't necessarily need to change it to an improper fraction if it's relatively easy for you to solve. So here we're going to solve it without changing it to an improper fraction. 37 minus 35, that works itself out. 37 minus 35 is 2. Now we work with the fractions. 7/8 minus 5/8 is 2/8. So the subtraction worked out very, very nicely. But 2 over 8 can be reduced. Divide the top and the bottom by 2. So your final answer is 2 1/4 inches. 2 1/4 inches. Problem 6. A rectangle has a length of 5 1/2 centimeters and a width of 3 3/8 centimeters. What is the area of the rectangle? Area equals length times width. So we're taking the length, 5 1/2, times the width, 3 3/8. 5 1/2 times 3 3/8. So we definitely need to start with converting everything over. Remember, multiplying and dividing, you don't have a choice but to change the mixed numbers to improper fractions. There's no choice in that. 2 times 5 is 10, plus 1 is 11. 8 times 3 is 24, plus 3 is 27. So now we go ahead and we do our computational work. 11 times 27 and 2 times 8. 2 times 8, I know is 16. 11 times 27, again, I have no shame with going off to the side and solving it out. Again, sometimes it's real quick to go and run and get that calculator. Remember, you're not going to always be allowed to use a calculator for everything that you do. So you got to learn somehow. So you got 297 over 16. That would be centimeters squared. But if you're a person that wants to change that to a mixed number, let's change it to a mixed number. So we have to figure out 297 divided by 16. 16 doesn't divide into 2. 16 divides into 29 one time. 1 times 16 is 16. And that leaves us with 13 when we subtract. Bring down to 7. So now I got to think a little bit with regards to how many times will 16 go into 137. So I'm going to go ahead and guess 8 times. So 8 times 6 is 48. 1 times 8 is 8, plus 4, 128. Relatively good guess. 8 times 16 is 128. And you have a remainder of 9. So that means you have 18 9/16. 9 over 16 cannot be reduced. Centimeters squared. So again, it does take some work, a little bit of arithmetic. Sometimes you got to do it off to the side, but sometimes that is what it is. That is what it is. And our final example together, example 7, you have to take 30 feet of rope and break it up into sections that are 2/3 feet long. How many sections of rope will you have? So you're taking a whole rope and you're breaking it into sections. Breaking it into sections means that this is a division problem. 30 divided by 2/3. So remember, before you do anything, make that whole number a fraction. It's a division problem. So keep the first fraction, change division to multiplication, and then you flip the second fraction. So you have 30 times 3, which is 90. 1 times 2, which is 2. And 90 divided by 2, just in case you need to see it. 2 goes into 9 4 times. And then 2 goes into 10 5 times. So that's 45 sections of rope that you will have. 45 sections of rope. And with that, that completes our journey through fractions. Again, adding, subtracting, multiplying, dividing fractions. You need to know how to change from mixed numbers to improper fractions. You need to know how to reduce, because this is where it primarily gets used when we're doing the computation. With that being said, your assignments with this content are the 2 IXLs associated with fractions. They are in your assignments packet, and they are also on Google Classroom. Of course, you have a Google mini quiz that lines up with today's work on fractions. Remember, for some of you, fractions are difficult. So if you have to constantly practice it to get it down, do what you have to do. You're in high school now. You're accountable for your learning, and you are responsible for your learning. Shoot me any emails if you have any questions. Other than that, have a great day.